see first verification of the theorem followed by Norton theorem. Aim and its application. So aim here is we have to verify Thevenin theorem for the given circuit and find the current through 10 ohm if connected across AB. So let's see theoretical calculations. So let us see the statement of Thevenin theorem and let us try to understand with respect to the small example. So a linear bilateral network, a two-terminal circuit, so that is A and B, can be replaced by an equivalent circuit consisting of, so they're saying that 1, 2, 3, 4, 5, these 5 passive elements, 1, 2, along with 2 active elements, can be replaced with an equivalent circuit consisting of a voltage source in series with the resistance. So they're saying that this circuit can be rewritten in the syntax, right? And then let us say you want to find you want a 1 ampere current here. This is an example. You want a 1 ampere current to point AB. Then you can find out what resistance you have to connect here so that you can derive 1 ampere, right? That's more easy, right? So that's the advantage of Thevenin theorem. So let me repeat: a linear network having 2 ends can be replaced by an equivalent circuit, that is, this is the equivalent circuit of one voltage source in series with the resistance, right? So where V is called as this VTH or VOC is called as open circuit voltage, and R is called as equivalent resistance, which is RTH, right? So do not bother about the rest part, that you'll understand when we solve problems, right? But here remember there are 2 types for Thevenin, Norton. They called as I would call it as type 1 and type 2. Type 1 with respect to independent sources, you can see here they've told something with respect to independent, so, and type 2 with respect to dependent sources. So there's a different pattern, a small variation with respect to dependent sources, but independent is quite easy. Dependent also is easy, but you have to there's one more step you have to do additionally. So let's see that. So let's say this is a problem given, and let's say they're asking us to find what is the current through AB, that is current through 10 ohms, right, by Thevenin theorem, right? So first step, remove the element which we're supposed to find, what we're supposed to find. So here in the question they've asked us to find current through 10 ohm. So remove the 10 ohm and rewrite your circuit, because 10 ohm is called as load resistance. So henceforth I'll be calling the 10 ohm as load resistance for Thevenin or Norton theorem. So this is your first step. Now after this you have to find what is VTH and ISC, right? I repeat, we have to find what is VTH and ISC. So what is VTH? VTH is your open circuit voltage and ISC is your short circuit current, right? So to find VTH, I'll be solving by nodal. You can solve by mesh. How many junctions can we mark? Pause the video to analyze how many junctions do we have. So we have 2 junctions as marked here, and I would be marking this junction as into V1, right? So why Vx, why not any other variable? Now you can see the drop across 15 is Vx, right? So I'll not use any other variable at this junction, because if I use V1, so you should know that V1 and Vx both are same, then it is fine. If not, it's better you use this as Vx. So whatever value of V1 or VA or Vx, whatever I get, right, or VB, that is same as this drop across 15 ohms. So both are actually same, right? It's better to use Vx, but if you know that V1 is equal to Vx, then you can go ahead. Now what is the value of current flowing through 30 ohms here? Do you think any current flows through this 30 ohms, right? So since there's no flow of current through 30 ohms, you can neglect it, right? You can neglect this 30 ohms. Next, so VTH is nothing but voltage above across this AB, or it is voltage above across 5, or voltage above across 15, or this voltage drop across this branch, which is nothing but Vx. Now the small question is, what do you think, what is the polarity across terminal A and B, right? So this is positive, terminal A is also positive, right, and this is negative, and this terminal B is also negative, right? So when you apply nodal analysis, this is your equation. How do we assume currents? Currents are leaving, and how many branches are there? There are 3 branches. This is your first branch, that is 5, second branch Vx by 15, and then the last branch Vx minus 150 minus Vx by 3, whole divided by 10. Right, so you can see if you take V1, you'll have here as V1 by 5, and then you will have here as V1 minus 150 minus Vx by 3, and you'll be in shock. How do I solve one equation but I have two variables called V1 and Vx? But when you know that this voltage drop Vx is also same as V1, then it is easy. Right, so I'll just show you the currents. This is I1, this is for first branch, second branch, and then third branch. So we assume all the currents are leaving, and then this is your nodal equation. So I'll just show you step by step how do we solve. I'll not explain as much because we've already done in previous videos. So as I solve, I'll be getting Vx as 75 volts. Right, so VTH or VOC or VAB or Vx all are same in this problem, which is 75 volts. Right, now second step, since we from the reduced circuit we've already found what is VTH or Vx or VAB. Now let us find what is ISC. Why we are finding ISC? We'll see that later. As I told, this is type 2 problem. Now to find ISC, you have to short circuit AB with a wire. Right, so let us short circuit with respect to AB with a wire. And remember, this 30 ohm which we had removed, we have to retain it back, because in your reduced circuit you can see here in this circuit, this is your first step. So from this step you have to find what is VTH and what is ISC. So 30 ohm is present, we have to use it. Right, so I'll be solving by nodal again. It is easy. Whichever method you have applied for step 1 to find VTH, kindly use the same for ISC also. And how many junctions to mark? It is same both. Right, so what do we mark here? Remember, we have to mark this as same as this voltage, that is Vx. Right, now you can see the 5 Vx by 15 and Vx minus 150 minus Vx by 3 whole divided by 10 is same as previous step. We have only one additional step. Right, this is what we have done previously. This current as well as this current. We have one more additional current, it is Vx whole divided by 30. That's all. So that this is that easy if you solve using same method with respect to step 1. So when you solve, you'll be getting Vx as 60 volt. Remember, Vx is 75 for VTH under a different condition. The condition was this was open circuited. Now this is closed and I have a additional 30 ohms. The entire circuit characteristics changes. I have a 60 volt drop across this 15 ohm now. ISC. The formula for ISC is this voltage. What is this ISC? Current through AB. Right. So by nodal, how do we write this current? As you can see here, this is nothing but Vx by 30. Right. So this current is nothing but ISC. Right. So Vx by 30 is your answer. So what is Vx? 60, and you get the answer as 2 amperes. So ISC is nothing but 2 amperes. Now, other than to theorem, they say that it's not like they say that you cannot find the resistance by shunting your dependent voltage source or dependent current source. So the method is you have to find the resistance using VTH and ISC, that is short open circuit voltage and short circuit current. So RTH is nothing but VTH by ISC, that is open circuit voltage and short circuit current, that is 75 by 2. Remember, the value of 60 that we have used to find ISC. Don't get confused. The value 75 that we have used earlier, that is VTH, and the value for the second time when we have calculated Vx, that is for ISC. So 75 by 2, that is 37.5 ohms. And I've told clearly in the theorems that the Thevenin equivalent is similar to an parallel practical voltage source, that is voltage source connected in series with the resistance. Right, now before writing the Thevenin equivalent circuit, I want you to go back and see 75 volts how we have solved. Now this is how we have solved. This is open circuited, we have solved by nodal, we have got Vx as 75. However, what was point A? We have assumed point A as positive, we have assumed point B as positive, and then the value is 75. This is important. I repeat, point A is positive, point B is negative, and it is 75 volts. Remember, point A is positive, right? So we'll see how do we write the Thevenin equivalent now. You can see point A is being positive and point B is being negative. This is important, right? So if you interchange this, you get some other answers for 10 ohms. I hope it's clear. If you have doubts, you can verify with me. And then the RTH should be in series with VTH across AB. But what was your load resistance? If you can recall, the load resistance was 10 ohm. So find the current flowing through 10 ohm, current through AB. Simple. Apply KVL in clockwise. Write the equation. You'll get the answer as 1.5789 amperes. And I'm sure this is quite easy. You'll be able to solve for this I. So 1.578 or 1.579 is your current flowing through your load resistance, right? So just imagine solving a single loop is easier, or applying mesh or something else to find here, right, in the original circuit, right? So applying 1 2 3, and this is not a super mesh, I mean this is not a mesh, rather super mesh, right? When you solve nodal, you'll have 1 2 3 4 branches, right? So when the circuit gets bigger and bigger, it's easy to reduce it to a small circuit, and then you can find the current, or you can accordingly you can find your load parameter. So whatever element you want to find, let us say you want to find, you need an voltage drop of 5 volts, or you need some standard value of current. So accordingly you can decide what is your load resistance. So we have seen here the value of VTH or VOC was 75, the value of ISC was 2 ampere, and the value of resistance was 37.5, and the value of current was 1.57 approximately. So let's see circuit connection in PSpice. So what all components are required? So as we can see, we need one VDC, we need one IDC, and we need 4 resistances, 1 2 3, and the load resistance of 10 ohm, and we need one common ground, and we need one dependent parameter E, right? So this is a dependent parameter E, which is nothing but voltage dependent voltage source. So where is the dependent parameter? It is here. And what is the gain? Gain is 1 by 3. So we'll see how do we substitute the value of gain here, and how do we simulate. So let's move on to simulation in PSpice. So let's say we have the first part named resistance, and let us place them accordingly. So let us rotate it here for the 10 ohms, and then we have 15 ohm, then we have one more 10 ohm, right? So we've taken all the 4 resistances. Let's take VDC, and positive is towards left, so let us rotate and place it before 10 ohm here, and we have one IDC going downwards, and the part name for dependent is E. Let us place it here. We require one common ground, that is EG and D, right? So when we've taken all the parts, let us try to connect them. So Ctrl with the shortcut in keypad. Let us value them. This is 10 ohm, this is 30, this is 5 amperes, this is 15 ohm, this is 150 volt, this is 10 ohm. Now the gain by default is 1, right? And when you substitute the gain as 1 by 3, it will not take the value. In the sense, it will not understand fractional. So let us find out what is 1 by 3. So 1 by 3 is 0.3333. Let us keep until 3 or 4 decimal points. So substitute this as 0.333. Okay, do not substitute as 1 by 3, it will not simulate. Keep this in your mind. Now, the one in the circle is a dependent parameter. You can see here, positive is counted at the terminal, negative is counted at the bottom. So this is same as the one which has been encircled. So from this positive is connected to the one end of terminal, and negative is connected to a common ground. Then where is the dependent parameter? The dependent parameter is Vx. Where is Vx in the circuit? It is across 15 ohm. And how? Top it's positive and at the bottom it is negative. So in the PSpice, top which is positive is connected at the top of 15 ohm, and negative of a dependent parameter is connected to your down to the bottom of 15 ohm. Right? Thus the circuit is now completed. Right? And what we have to find? One is to find current through AB. Right? So if you remember, here we had A, and this was actually your B. Now we need to find current going downwards. Go to markers, take mark current, and we need to find current going down, so place the marker at the top. Now as it's a DC circuit, we will not bother about the time, so just enable transients and save your file. And let us simulate to check our output. Now we are getting our answer as 1.5789 without applying Thevenin theorem, right? So what was our answer when we had simulated, when we have theoretically calculated? The answer was 1.5789, and here also we are getting same using Thevenin theorem. But let us verify the Thevenin theorem, in the sense we need to verify for VTH as well as ISC. So what you can do is first delete your current marker. As we know the circuit is correct, let us select all over here. Right? I'm pressing Ctrl C my keypad and Ctrl V to paste. So I'll be placing this twice, first, second. Right? Now as I do that, I'll rename this as R2 as load. I'll rename this as load. And I'll here in this circuit I'll find VTH, so I'll rename R8 as VTH, and this one's for ISC. I'll rename this as ISC. Now we know under VTH the resistor has to be removed, right? And under RTH this has to be short circuited. So what I'll do is I'll remove this and I'll short circuit this with a wire, and I'll rename this wire as ISC. Okay, or what I'll do is I'll try to find, and I know the same current travels to 30 ohm, I'll rename R10 as ISC. Right? So now we cannot find a voltage, the circuit has to be closed, right? Or else one cannot find the value of the resistance or voltage. Let us try to simulate and see what error do we get. Let me first keep the voltage marker, so we know top it is positive, bottom is negative. Let me place a current marker, right? One for the load resistance and one for ISC. So when you keep here, you get an error, so you have to place the end of element. Now you know ISC you have to find from A to B, that I must find going left here and then down. So since I must find the current going left, I must place the current marker at the right. Now if I simulate, do I get any error or not? Let us just check. It says error because circuit for VTH it's open, right? So what we can do here is, I want you to think, how can I complete the circuit? However, the circuit parameters the electrical parameters should not change. I want to think, pause the video, think what can we do, then you can resume and then check your answers. What I would do here is I would place a resistance of high value. just creating an open circuit. So what I've done here is I've just placed the voltage, right, of a large value. I've placed a resistance, sorry, of a large value, thus creating an open circuit. And I rename R13 as VTH, right? And then I'll bring this voltage probe here so that in your output you can see voltage across this resistance, in turn that is VTH, right? So now let us try to simulate and see whether we get any errors. Now toggle cursor, so let us check VTH 74.993, but we got 75, and ISC is 2. Now why aren't we getting 75 exactly? Why are we getting 74.998, which is approximately 75? Now to get your answers, what you can do here is try to go to your gain. Now this is a recurring decimal point 0.3, so try to add on some more 3's, right? Now let us see what value of VTH do we get now. Now we get 75, right? So I hope you understood the difference, as the gain is a fraction 1 by 3, but when you calculate, you've taken the complete answer of 1 by 3, right? But here we have just given few decimal points only, so the more decimal points, the answer is more accurate. Similarly for ISC also, we have got it as 2, right? And this is your load current 1.5789. But I want you to observe the difference, how we have got the current 1.5789. Now here we have not solved for Thevenin equivalent circuit. We have just solved for the given circuit and find out the current, right? So this is how we can verify for your Thevenin voltages, VTH, and the Thevenin current, or the short circuit current, ISC, and then the load current through it, that is I. Now let us try to build Thevenin equivalent also. So what is your Thevenin equivalent? So VTH in series with the resistance. So I'll copy this voltage and I'll try to rotate it and I'll place it here, and I need a resistance, so I'll copy here and I'll place it, and the load resistance is about 10 ohm, and we know the value of RTH is 37.5, the value of VTH is 75, the value of load resistance is 10 ohm. So let me connect this. So let me take common ground. Now current marker. How? We have found the current going through AB. This was A and this was B. So I'll place here. Now, so this is R15. This is by Thevenin equivalent. So let me try to simulate now and show that we get still same answer. So R15, as I told, we get same answer, 1.5789 or approximately 1.579, right? So this is how one has to solve and find out your answers for your Thevenin theorem. Thank you.